This is CMP204. It's about building a cost, energy, and resource-efficient compute environment and running this environment. And as this session happens right after the lunch, I want to kick it off with a question. Who of you is running a large compute environment? OK, a few of you, keep your hands up. Keep your hands up if you're running this in an efficient way. OK. I think there will be something you can learn from this session, hopefully, and improve this. So I'm solutions architect at AWS. I'm helping customers to optimize their architectures on AWS regarding security, reliability, and so on, but also sustainability and cost and performance. And I'm here today with Adam Böcklin from AWS and Troy Gazaway from ARM. And the agenda for this session is that I will first introduce you to a few KPIs and metrics which you can use to measure your efficiency. Afterwards, Adam will talk about concrete optimizations, deep dives into that. And after that, Troy will tell more about ARM's journey for optimization. And I want you to leave this session, preferably at the end, with some hints, with some tricks which you can apply to your architectures, and with some pointers to guidance where you can start your own optimization journey. Every journey starts with a goal, and a common goal is that customers want to optimize for cost, or that customers want to optimize for greenhouse gas emissions. And cost often relates to AWS spend, and the emissions relate to greenhouse gas emissions as defined by the Greenhouse Gas Protocol, in which customers are reporting their emissions in different scopes, and AWS and other vendors actually are in their scope 3. If we take a step back from these output goals, from these outputs, and take a look at the inputs, we see the bigger picture. We see that cost is a simple function of your AWS service usage, some purchase options, and the pricing term of a service. The emissions are more complicated, but it boils down to two things. It's the energy which is necessary to run these services for your workloads. That is AWS Scope 2 in the Greenhouse Gas Protocol, the Scope 2 of AWS, and the emissions which are required to create all this hardware, the server hardware infrastructure, to produce the servers, to ship it, and to eventually recycle it. And that is Scope 3 in the Greenhouse Gas Protocol. And we can extend the picture even more and look at and also create a mental map which we will use during this talk from left to right. The services are used by operational processes. And these processes are run to fulfill business needs. And it's important to know these three parts which I marked here as green, because efficiency is the least amount of resources to fulfill your business needs. And that's why it's very important to know the business needs of your users. Also, looking at all three here reveals further cost optimization opportunities in the area of operational processes. And the earlier you look for improvements, for efficiency improvements, the more and the bigger the effect is on your output goals, on all three output goals, cost, reduction of cost, and energy and physical resources. Traditional IT infrastructure can have a lot of waste, and it's hard to figure out where to start. Ideally, you go through these outputs and inputs in the chain, which I've shown you before, and create a map of weighted areas. This here is just an example, and it's even independent of the cloud. And you can imagine if you move your workloads to the cloud, you can shift some of these blocks here into the responsibility of AWS. And with such a map, you can focus and identify the big rocks where you should start your optimization. If you want to optimize for efficiency, look at your business needs first. Look at what are your users? What is the system context? What are the business needs? Are these business needs still necessary, are still asked for, or have these changed in the recent past? It can happen that if you have a large infrastructure, some of those data which you process, which you provide in interfaces is no longer needed. And also capture and define what are the SLAs that you promise to your users. You should know about the availability, disaster recovery, the response time requirements, so you can make architectural trade-offs. And when looking for the operational processes, also look for opportunities to reduce the undifferentiated heavy lifting, to reduce the capacity planning effort, the purchasing planning, the purchase processes, or shift the work to manage some services to AWS by using more managed services. Having done that, you should track your service use. We found that an effective way requires KPI and metrics that can be consumed by both application teams and also management. So it's important that you can break down your service use to certain teams, to certain time frames, and to certain usage types. So every application team can own their optimizations. And management, on the other hand, would look at the big blocks to identify and understand where they should invest with further deep dives and reviews. This is an example for service use, how you can present it. These bars here are representing different applications, different application teams in your application landscape. And this data could be pulled just from the AWS cost and usage report and then presented in Amazon QuickSight to build a dashboard and show it back to teams. These bars could either be dedicated accounts or it could be tags in your tagged resources in your account. And this is a typical chart which customers can use as an indication where they start their optimizations, typically with the big bars on the left, where they can use run some reviews. The selection for the unit here, for this unit on the y-axis is important. I see sometimes customers are using instance count or instance hours to compare applications, but this is not a good metric to compare. Some applications might run several or many small instances just for a few minutes. Other applications might run very big instances for the full month. So it's important that you, for comparison, that you normalize this. And I want to spend a few minutes on good normalization, which you can do for your metrics and KPIs. As a first step, you should normalize your usage. Use the information about the instance types and multiply the instance hours with the number of vCPU that instance has. Or use normalization factors as we provided in the reserved instances documentation factors which you can use for multiplying and having normalized instances. And the same, basically, we're talking a lot about compute here in this session, but the same would apply to storage. Do not only count buckets. Do not only count the number of volumes or the number of files. Really use gigabyte hours to compare the different projects with each other. Then, to be suitable as a KPI to track, you need to calculate the ratio of the desired usage with the total usage in the denominator. And that's already the definition of CPU utilization. But if your goals are, for example, the spot adoption, that would be then the spot vCPU hours divided by all vCPU hours. Or if your goal is Graviton adoption, that could be the count of lambda functions, of Graviton lambda functions, divided by all lambda functions you have. Back to the idea that efficiency is the least amount of resources to fulfill your business need. And that's why KPIs should also reflect your business units of work. That could be the cost per monthly active user, or the vCPU per insurance policy processed. So you should have these KPIs, which then help the team to compare their performance of the last month or the year before, even when the business is growing or shrinking at Christmas time or so. Having your KPIs, you can define goals and run a typical plan, build, measure, repeat process. This improvement process here, which I'm showing, is taken from the AWS Well-Architected framework sustainability pillar. And this is an iterative process. It starts by first looking at your whole landscape, then identifying and prioritizing workloads by usage type or the impact a small change would have. Then you evaluate improvements, making hypotheses like, I could implement autoscaling, I could do right-sizing, I could make an architectural change. Then you optimize these improvements by risk and cost and by impact, and then you experiment. First in the test environment, then you deploy to production, then you measure. If you have unwanted outcomes, you would, of course, revert that change. If the change was good, you look for opportunities to also do the same change in other applications, and then go to the next hypothesis. Adam and Troy will later give you some examples for optimizations which you can apply and which are successful. But before, I want to say that you're not alone on this journey. I said earlier that cost is a function of your AWS service usage and the pricing terms. But AWS service teams are continuously looking for ways to improve these services using AWS economy of scale, and they pass on the savings which they get from improvements in this area to the customers. So we indeed already reduced the service pricing 115 times, and that is the result of that. So we are also having a part here. Same with energy and physical resources. The Scope 3 and 2 emissions are a result of AWS architecture, AWS trade-offs, and operations. And it also matters what is the energy that Amazon purchases. These optimizations can be found in the 451 research reports. 451 research took enterprise data centers and compared these to the cloud to quantify the sustainability improvement, the sustainability benefit if you would move to AWS in US, in Europe, and in APAC. And they found that the major benefit by a shift would result from the energy reduction. We say the greenest energy is the energy that we don't use. And they quantify that nearly 80% of during the shift is according to the energy reduction. So you can save 80% of the energy by moving your workload to AWS, and that comes from more efficient servers, higher utilization of the infrastructure, and more efficient facilities. And once AWS is powered by 100% renewable energies, that also accounts or contributes to a reduction of 96% of the carbon footprint. And by the way, we are not only optimizing for energy. Energy is not the only resource AWS does optimize for. You might have heard today in Adam's keynote that we also take care of water, and we committed to being water positive by 2030. So it's not the only resource we optimize for. For the carbon emissions, the individual result for your applications and your accounts can be measured and seen in the emission estimate in the AWS Customer Carbon Footprint tool. Who is using that tool already? Quite a few. Okay, you should take a look at it. It's available in every account. You go to the billing console, and you will see it there next to the cost and usage reports. It lets track you the emissions of your workloads there. You can understand the historical footprint of this account by month, and you can also see a forecast of your emissions based on your usage and based on AWS renewable energy projects running. And this one here it's not an either-or discussion of having metrics and KPIs from the cost and usage reports or using the customer carbon footprint tool. You should do both. They complement each other. So you have the emissions view, but you also have this very fine-grained usage view which you can establish with such dashboards. After this quick intro of metrics and KPIs to identify workloads for optimizations, I want to hand over to Adam, who will talk more about concrete optimization techniques. Over to you.
Thank you. All right, cool. Thanks, Stefan. My name is Adam Beglin, and I am a specialist on the EC2 team focused on efficiency and sustainability. So that means my job is to literally help customers spend less on AWS and use fewer resources. So I get paid to do that, which is kind of crazy when you think about it. But it's awesome, and I love that we invest in that. And so I want to help you guys with some of the tools and resources that we have available to help you run more efficiently on AWS. And I want to start with, excuse me, EC2 instances, because everything on AWS runs on EC2. Whether you're running, Lambda or Fargate or straight auto scaling, at the end of the day, you're running on EC2 instances. And if you've been around for a while, you've probably noticed a massive explosion in the number of instances that we have. We even launched, I think I saw at least a dozen in the last couple of days. And when I joined back in 2014, we had 30 instance types. And I remember even back then thinking, wow, how am I ever going to keep up with all this? Now with over 500, we give you options for super high frequency, network throughput, local instance storage. And this choice is great. And all these options are awesome because it lets you pick the instances that are best suited for your workloads. Because our goal is to help you find the instances that best match your needs. The downside of this is that, with all these instances to navigate, it can be hard to, keep track or figure out which ones to use. I mean, this is my job, and I still need a cheat sheet whenever I'm in a meeting with a customer and they ask me specs on an R7GN 4X large or whatever. I'll never remember that. I just can't. And I don't think that you should either. I actually, and this may be, controversial, but I don't think that you should know or care about our instance sizes or names at all. And instead, just start thinking about what the resources you need for your application is. And kind of flip that model on the head from switching from which server do I need to what resources I need. Okay, so I'm going to do something, it's a little cheesy, but I want you to bear with me. I want you to take a second and think about one of the applications that you manage. And think about and kind of spec out, what is the minimum that you need for that app to get up and running and start doing some meaningful work. So maybe you have an API or a Java app. How much memory do you need to just get the app up and running and handle requests in a reasonable amount of time? Do you have local disk requirements or throughput or things like that? Okay, got it? Now think of how many units of work, whether that's requests or things that you're processing that your app can do before you need to add more resources. All right, got that? Jot it down, take a note, because you now have everything you need to configure auto-scaling to automatically pick your instances for you. And you can do this with a feature that we launched at re:Invent last year called attribute-based instance selection, or you might call it ABIS because it's a very long name. But I think that it's one of the most powerful tools we have to shift from a server focus, an instance focus, to an application focus. To instead of you trying to hunt through all of our spec sheets and marketing pages and third-party websites that do a better job than we do at listing out our instance config, just think about what your app needs. And when you use attribute-based instance selection, we take care of picking the best instance for the job. So you don't need to know what we launched at re:Invent this year. You don't need to keep up with our blogs. You don't need to know what instances are in what region, because auto-scaling will do all of that for you automatically. And that's really cool. But that's not the only benefit that you get. Moving from an instance focus to a resource focus, it opens up a lot more opportunities for savings and for optimization. And one of the really amazing tools that I think that we have from an efficiency standpoint, from a sustainability standpoint, are our Spot instances. So with AWS or EC2 Spot instances, you're literally helping us reduce the waste that we have within our data centers. So we're going to pass the savings down to you as the customer. So if you haven't heard of Spot, let me kind of give you an overview of how that works. We have a lot of customers who scale up and down based on demand throughout the day. But to be able to handle that scale and to be able to allow customers to launch new instances when they need it, we need a certain amount of free capacity sitting there within our data centers. Now, we have lots of algorithms and capacity planning and teams that try to make sure that we have as little as possible to, that's sitting there idle, but we do need that idle resources. And because of the scale that we operate at, it actually ends up being a massive amount of compute. But like Stefan said, we want to run our data centers efficiently, and we want those servers to be doing meaningful work. So to incentivize you to use them, we're going to offer you that spare capacity at a significant discount, sometimes up to 90% off of the on-demand price. Now, the caveat with Spot is that if a customer does come in and says, hey, I'm willing to pay full price for this instance, we're going to shut down that instance, we're going to terminate it, and give it to that customer who's willing to pay full price. Now, it's not as scary as it sounds, especially if you've built a stateless application or have a batch workload that's designed for failure and you can restart it on another instance. And we also give you a 2-minute notice. So if you have the ability to, you can wrap up any work and save it and restart it whenever a new instance launches. And that's where attribute-based instance selection or even just being flexible with your instance choice really comes in handy. The way that we manage capacity with EC2 is we have it kind of split into, we call them pools. So each instance type and size is its own pool within each availability zone. So if you're running Spot and you're in US East 1A and you're using M4 large, and another customer comes in and says, hey, I want that instance at full price on demand, we're going to take that instance, or that'll deplete that capacity pool. But because you're using attribute-based instance selection, and you told us you just need 4 vCPUs and 8 gigs of RAM, we can launch that on an M5 large instead, because that is a separate pool with its own price that is also, it may be slightly higher, but it's still going to be significantly less than that on-demand price. So this is really where the magic of attribute-based instance selection really comes in. It's really great, even if you're not using Spot, even for on-demand. Sometimes some instances do get popular in specific availability zones. And by having that flexibility, you can make sure that you get the resources you need for your application, regardless of where you're operating at. But it's especially useful with Spot when it comes to cost savings. And I'm not going to go too much into detail of these customer slides. We actually going to have Troy from ARM come up here in a few minutes to tell you about his journey and his savings with Spot. But I do want to highlight that there's a lot of applications that can take advantage of Spot for their workloads. You have companies like Lyft who save 70% off of their CI/CD workloads just by changing 4 lines of code. Or Skyscanner, who saves 74% by moving their Kubernetes cluster to Spot. So I want your takeaway to be that it doesn't matter what you're running, there's probably an amount of your infrastructure that could run on Spot, and that'll help you save money and help us run our data centers more efficiently. So it's really a win-win. But the reality is that not every application is fault tolerant. Not every application can handle failure. Things like databases aren't designed to constantly be failing over from AZ to AZ or from instance type to instance type. So that's why most of our customers who are highly optimized, at least for cost, use all of the purchase options that we have available. So you're probably already familiar with on-demand because that's what most customers start with, at least. It's where what you get by default. You pay the most for it, but it's great because when you're starting out, you don't know what you need or how long you need it or what your scale is going to be. But if you've been using AWS for a little bit, you'll probably see that there's a certain amount of compute that you're always running. And that's regardless of how it's managed, whether it's Kubernetes or Lambda or anything like that. And the great thing is that whenever you know that, you can start looking at savings plans for everything that isn't a good fit for Spot. And we try to make it as easy as possible for you to use savings plans. So with savings plans, you don't need to do any code changes. You don't need to configure your infrastructure or launch instances differently. Heck, you don't even need to know what type of instance you're going to be running. You just bring up the AWS Cost Management console, review the suggestions that we provide for you based on your historic usage, choose if and how much you want to pay up front and how long you're willing to commit for. And if you've chosen, let's say an all upfront 3-year commitment, you can save up to 72% off of your EC2 bill, all without literally doing anything to your application. And we do this because the more certainty that you can give us about what you're going to be running, the less spare capacity we need in our data centers, so the less waste we have, and the more we can pass on that savings to you. And the last topic that I want to talk about when it comes to efficiency and optimization is your processor choice. So if you're using attribute-based instance selection, this is going to be one of those options that you have. And most customers, most applications in the world, they're still using x86 by default. So these are Intel or AMD processors. But that's what we've been running for years. It's, I've built my applications, historically on x86. It's easy, it's what we know. But ARM-based processors have come a long way, especially in recent years. And they're far more efficient than these traditional processors while providing, similar or even better performance in some case. Now, Troy's here from ARM, who will, go deeper into the processors later, so I'll let him do that. But I want to highlight that the AWS-developed Graviton processors, or at least the instances that use them, are around 20% lower cost just right off the top compared to their x86 counterparts. And when you factor in performance, they have 40% better price performance than x86 instances. And this goes back to Stefan's point about building and measuring KPIs. So because these Graviton processors are cheaper, but they're also faster, on average, it'll cost you 40% less to get the same amount of work done on Graviton compared to a traditional x86 instance that most customers have historically been running. And since this talk is about efficiency and sustainability, cost shouldn't be your only concern. I mentioned earlier how much more efficient the ARM architecture is, but it's really easy to underestimate just how significant that difference is. Graviton processors use up to 60% less energy to provide the same level of performance as x86 processors. That means they use less power, they generate less heat, they require less cooling, and they can be built with higher densities within our data centers. This is one of the reasons why we can offer them cheaper, but also why they have less of an impact on the environment. If you're using an ARM-based laptop today, or heck, your phone has had an ARM processor in it for years, you know how amazing the battery life can be, especially with the modern processors. So I'm really excited that we can bring that sort of power efficiency into our data centers with Graviton. And one of the last things I want to leave you with before Troy comes up is, I want to remind you that this is a journey. And depending on where you are on that journey, you're going to need different tools to help you run more efficiently. I already mentioned the cost management console for recommendations on savings plans, but that's not the only tool that we have available. I also highly suggest you check out AWS Trusted Advisor and AWS Compute Optimizer. Now, they both look at different ways of managing efficiency and usage within your account. But if you follow their suggestions, I know you'll be able to lower your AWS bill and get the most out of the resources that you're running on AWS. But now I want to introduce Troy Gasaway from ARM, who I invited to tell his story about optimization and efficiency. Thanks, Troy.
Thank you, Adam. Hello. Thank you for being here because you care about the planet. My name is Troy Gasaway, and I'm the Vice President of Infrastructure and Engineering at ARM. Quick intro to ARM. We don't build CPUs ourselves, but we license CPU designs to most of the world's silicon providers. Over 70% of the world's population uses ARM-based technology. Our technology shows up in everything from your smartphone to your television, all the way to servers and supercomputers. To date, over 240 billion ARM-based processors have shipped. And last year alone, our partners shipped over 29 billion. One of those partners is AWS. The AWS Nitro chip, which delivers networking, storage, and security services to all of AWS's new instance types, is based on our technology. And if you're familiar with the Graviton family of instances, that is also based on ARM technology. If you're not familiar with Graviton, I highly encourage you to check it out. With Graviton 2, AWS is able to deliver 40% more performance per dollar as compared to 5th generation x86. And with the Graviton 3, not only are the vCPUs faster, but you can complete the same workload and consume up to 60% less energy, as Adam mentioned. There we go. Please don't get lost in this slide. All I'm trying to illustrate here is there is a lot that goes into building and designing a CPU. But if I could ask you to take two things away, it would be one, to design and build a modern CPU, what AWS and Annapurna Labs does, can cost well over $100 million. Two, a design flaw is very expensive. Therefore, it is critical that we complete sufficient verification to reduce that risk. To simulate and test the design, what ARM does can take hundreds of millions of CPU hours. Okay, so to demonstrate how AWS helps ARM build a sustainable compute infrastructure, I'd like to go through a couple of the key benefits and differences that we get with cloud versus on-prem. In our on-prem environment, we effectively offer two SKUs, a high memory configuration and a low memory configuration. The challenge here is our engineers being cautious. They would typically pick the high memory configuration. And that's a reasonable choice when you don't fully understand the needs of your workload, which is really common for new products. The consequence is we ended up with an inefficient use of our memory, which is more waste that we have in our environment. With cloud, this problem is flipped on its head. Now we have access to hundreds of instance types, and the problem becomes finding the right instance type for our workload. Good a problem to have, but a problem nonetheless. We solved this by having a team that benchmarks the different instance types available against our workloads and tools. This graph represents a single EDA workload with multiple phases. Those are the different colors that you see. The top line is our on-prem infrastructure, and every line below that is a different instance type with a different thread count. So now we have the ability to always find an instance type that is perfectly sized for our workload, eliminating any waste. Having the right tool for the job is great, but our biggest challenge with on-prem was just not having enough capacity to get the job done. One of the challenges of being capacity constrained is it doesn't make good use of our highly valuable engineers. Pen time is a term that we use on-prem that indicates how long a job sits in a queue before it's dispatched for processing. Before moving to the cloud, we averaged 9 minutes of pen time. So 9 minutes before a job would actually be submitted for processing. 85% of our jobs finish in under 5 minutes. That means that our engineers spend 60% of their time waiting for their jobs to execute. Contrast that with cloud, where we have virtually unlimited capacity. The graph on the right-hand side is a graph from the beginning of our journey. You can see earlier this year that we peaked at over 175 million vCPU hours in a month. That is roughly almost 3 times what we can deliver with our on-prem infrastructure. From a people efficiency standpoint, our engineers are no longer constrained by our compute. So the beauty of cloud is we have gone from being compute constrained to being engineer constrained. It's a good problem to have. And by the way, we are hiring. Across our various data centers, our engineers had access to roughly 125,000 slots. Think of a slot as a vCPU or a core. Before cloud, let me not read the same line twice. So, before cloud, when we had access to this fixed capacity, we had to do what I call beating the demand flat. Any excess demand had to be pushed out over time. This resulted in projects taking longer to complete, and we couldn't take on as many customer requests. This was really holding back our business. In the cloud, we have bursted over 350,000 slots, vCPUs. As I showed you earlier, building chips is very expensive. Therefore, delivering quality IP is perhaps one of the most critical aspects of our business. Chip design using EDA tools is a really big optimization problem. And that's where machine learning is great. We've been able to unleash machine learning on our simulation workloads and reduce those by over 1,000 times. So being able to complete more projects quicker and to do so with even greater quality means everything to our business. Happier customers and a happier planet. The dots on the next two slides are products on our roadmap. This is our 2018 roadmap before we started our journey to the cloud. This shows the before and after effect that cloud has had on our business. This is Arm's answer to the question, if you have unlimited compute capacity, what would you do with it? By the way, that's a fantastic question for all of you in the audience to ask yourself this week while you're out here at reInvent. Visually, you can see the pace of innovation that unlimited CPU capacity has allowed us to achieve. Each of these dots represents customer activity. We're all here at reInvent this week. Cloud Computing Show. Arm is in the AWS cloud, but we're in all of the major cloud providers. So again, ask yourselves while you're out here this week, what would I do if I had unlimited compute capacity? Cloud helps improve our cost efficiency. As I mentioned, 85% of our jobs finish in under 5 minutes. That is a perfect match for Spot. And I'm sure, as you know, Spot is a highly discounted pricing model from AWS, as Adam mentioned. 88% of our EC2 instances use Spot. For the other 12%, we predominantly use savings plans. Those are a good match for our workloads that have longer runtime requirements. Of course, we're trying to run as much of our workloads on Graviton as we possibly can. The Graviton family offers the best price per performance available in the AWS cloud. We also have a corporate goal to run Arm's business on Arm's processors. This is a project we call Arm on Arm. Arm on Arm is a strategic goal for us. But make no mistake, we're not doing this out of pride. Arm processors offer more performance, a lower cost, and can complete the same workload, consuming up to 60% less energy. From a sustainability standpoint, turning idle spot capacity into productive capacity is a win for us. We take idle capacity and we put it to work, significantly reducing the carbon load created by developing our products. Arm on Arm is good for the planet, and it allows us to do more with less. How we do more with less, you might ask. This slide shows how. Generation over generation, Graviton has made significant performance gains. These are our measurements of a single EDA workload. Your measurements and mileage may vary. You can see not only the progress Graviton has made, but the raw performance benefit. And then consider price. For the same workload, the latest generation of Graviton is 50% less expensive than the latest generation of x86 with the C6i. From a sustainability standpoint, that allows us to use fewer instances, again, reducing the carbon load created by our products. Okay, I've talked all about the great benefits we're seeing from our move to the cloud. Some of you may be wondering how we did it. We went down two parallel paths to create a hybrid environment where we could dispatch jobs to the cloud and make this transparent and seamless to our engineers. We created a RESTful API-driven tool we called Cloud Runner. When an engineer dispatches a job to Cloud Runner, it identifies available capacity, manages the creation of the job with Kubernetes and EKS, submits the job, processes it, tears it down, and releases the resources. This is a tool we created in-house, but we are investigating other tools from third parties like Rescale. To enable some of our more complex workloads, we created another platform we called the Cloud Foundation Platform. This is a combination of a number of commercially available applications, so anyone could build this. But what it did is it let us take those proven existing applications and make them appropriate for the cloud. For example, with IBM LSF, we have integrated that with AWS's Spot API to allow us to leverage Spot instances. This is all contained in our AWS landing zone, where we have a number of policies or guardrails in place to protect ARM. This allows us to give our engineers freedom to work autonomously, knowing that those accounts are secure, that we have complete cost monitoring over them, and that they can only spin up approved resources. In fact, we have over 200 accounts in our AWS landing zone. Knowing the projects that we're working on, the cost of those allows us to track the total cost of ownership for our projects. This is not something that was feasible for us with our on-prem environment. So, in summary, moving to the cloud has been transformational to ARM's business. We've moved from being capacity constrained to being engineer constrained. With cloud, we have unlimited scalability and right-sized instances on demand. This gives us the opportunity to try out new techniques like machine learning. We are fortunate that our workloads are a good fit for Spot, but we do leverage AWS savings plans for those more difficult workloads that have longer runtime requirements. We're continuing to increase our adoption of Graviton. From a sustainability standpoint, and to be able to do more with less, Spot with Graviton is ideal. If you haven't tried Graviton, we highly encourage you to do so. You won't regret it. And if you need any more evidence that running in the AWS cloud on Graviton has been great for ARM's business, we actually won the 2022 Editor's Choice Award for the best use case of HPC in the cloud at the Supercomputing Conference last month or the month before. All the days run together. Let me turn this back over to Adam. Thank you all very much for your time.
Thank you, Troy. I really love that part of ARM's journey where they save money and get more done. Like, I think that's super cool, and one of the reasons I wanted him to talk about how they were able to do it. So we've covered a lot today, so I'm going to leave you all with just a couple final thoughts. And one of the themes that we've talked about is about how flexibility and choosing the right options can increase your efficiency. But another way to think about that is that the more you can tell us what you need and the less you tell us how you need it, the more efficient we're going to be able to help you run. And I mentioned this earlier with the idea of attribute-based auto-scaling or instance selection, but you could also look at it from like an AWS service perspective. Let's take this graph, for example. It's got two very different sides and two very different approaches to managing compute. On the left side, we've got EC2, and we have a lot of customers who build and manage their EC2 infrastructure, do auto-scaling, do patching, pick the right instances, and do all that. And it's possible to run efficiently, but it takes a lot of work and a lot of time and effort. Whereas on the right side of the graph, you've got Lambda, where you write code, you point it at an API endpoint, and you let us do all the work of scaling and lifecycle management and managing that resource utilization. So I want one of your takeaways to be that the less opinionated you can be on how you want your infrastructure to look, the more options we have at AWS to run that as efficiently as possible because, like Stefan said, we have a lot of engineers, we do a lot of work to try to get the most out of our infrastructure, and a lot of the services are constantly improving. And that's because just like security, efficiency and sustainability, it is a shared responsibility. We provide a lot of tools and documentation and things like the Compute Optimizer and Trusted Advisor to help you along the way. But we also have partners and professional services if you need help there as well. And the last thing that I want to highlight that we provide that I think really ties together everything that we covered today is the Well-Architected framework. So this is a framework. It's also a tool to help you evaluate your applications against best practices. It has a lot of different pillars. I think that we're up to 6 now. But the pillars around cost optimization, performance, and sustainability all fit directly into our themes of efficiency and getting the most out of what you have. So if you haven't already, highly recommend that you check out Well-Architected to kind of help you with all of the things that we've talked about. And if you want some recommendations for sessions to view, we've got quite a few at reInvent this year, talking about sustainability, talking about Graviton, talking about efficiency, which is awesome. I love that this is now a topic that people care about and that we are building content for. So with that, I want to wish you the best on your optimization journey. If you have any questions, we'll be around in the back of the room. Yeah, thank you, and take a second and appreciate it. Thanks.